Start it again. Finding your seats. Thank you. All right. So as Dr. Braddock mentioned this morning, one of the early activities of the Institute was to advocate for a National Center on Cognitive Disability and Technology, and to be administered by the National Institute on Disability, Independent Living, and Rehabilitation Research, formerly known as NIDR. The power of persuasion that the Coleman Institute had allowed the competition for a rehabilitation engineering research center on advancing cognitive technologies. In 2004, Dr. Cathy Bodine and her team competed successfully for the center and have done so in 2009 all the way leading up to 2014. They have now been funded for 15 consecutive years. Yes. Their longevity and innovation in research in this area validates their title of Technology Futurist. And to provide you with some insights, I'd like to introduce Dr. Cathy Bodine.
Thank you, dear. Okay, so being asked to be a futurist is kind of exciting, but then it puts a lot of weight on you because then you're supposed to know something. So you got to think about this a little bit. So let's see how this works. Okay, so before I get started, and I have just a short time, but I have to acknowledge my team at Assistive Technology Partners and throughout the University of Colorado, Anschutz Medical Campus, as well as the Boulder campus. For the project, I'm just going to talk about one project, and it's a project we've just launched. So it's kind of interesting that I'm talking about something we haven't finished yet, but it's a project I'm very excited about, and I want to acknowledge my team for the work they've done. And of course, our funding, as Shay indicated, for this particular project is through the National Institute on Disability, Independent Living, and Rehabilitation Research. So we've talked a lot today about cognitive accessibility. And we talked a lot about the future, and we talked a lot about how cool this stuff is, right? It's pretty cool. But what does it really look like for people with cognitive disabilities, and how do we really get from point A to point B? And how alike or different are people with cognitive disabilities or differing cognitive abilities? So if you think for just a second, each person in this room probably has their own definition of what cognitive accessibility looks like. And if we had the time to go around the room, I betcha we'd have lots of different opinions on what cognitive accessibility really is. And I think that's important. And that's kind of what's driving this particular project. We're talking about autonomous vehicles, hyperspeed 5G, we're talking about augmented virtual reality, we're talking about all of these cool technologies that are absolutely right on our doorstep. But how do we make it equitable? And how does it really look for people with cognitive disabilities? I just want to, neuro's like one of my favorite things in life. So just to let you know, just to think just a little bit, I want you to look at a few brain scans very quickly. We're all physicians here. I know we understand this. But my point is, cognitive differences exist across the spectrum. So for example, let's see if this goes backwards. Someone with a mild cognitive impairment does not necessarily look like someone with Alzheimer's disease or a senior whose brain is slowly getting smaller as we age, and it does happen to all of us. Someone with cerebral palsy, dependent on where the brain lesion is, does not necessarily look the same inside as someone with Down syndrome, Fragile X, autism, pick one, it really doesn't matter. The point is, and those of you that are in neuro, you've seen this slide back in freshman neuroanatomy class. The point that I want to make with just this slide is, depending on what's going on in the brain, different things happen to our visual perception, our memory skills, our reasoning, our judgment, our thinking, our remembering. All of these things can be different. But Every single thing in the brain is connected and wired together. So, what do you see when you look at these mobile devices? Look pretty intuitive, don't they? Not so much. Think about someone who has a difference in their brain. How do you think this looks to that person? And how do you think they're going to interact with it? We talk about voice recognition. We talk about all these different ways we're going to interact with technology. But let's remember the brain operates differently for all of us. There is no one-size-fits-all in cognitive accessibility. We can't say we've invented X and it's accessible for every single person that has differences in their cognition. Kind of logical, right? So what do we do about this? How do we ensure that we're thinking about cognitive accessibility? Well, I just wanted to put this up. Has anybody seen the new the Google mobile app look? You notice all that red on it? Just saying, how many people with cognitive differences have visual perceptual problems with color? Quite a few. So just saying. All of our developers have guidelines that they use to put these technologies out on the market. And each of them approach it from a very different perspective. And we don't have time today to go into it, but there's lots of differences among all of these things. So what does cognitive accessibility mean? So we started working several years ago on cognitive standards. We're now working with the ISO group on moving our standard over to ISO. And at first we were really looking around hardware requirements, right? And how do we test and disclose what the technical specifications are. Now we're moving into looking at user interface on mobile devices, on tablets, on phones, on those types of things. But what have we learned? We started our product usability testing lab 9-10 years ago now. And what's cool about my shop is that we have clinicians as well as engineers thinking about these things at the same time. And we know from a clinical perspective that what works for one person doesn't necessarily work for another. And we've found that out in our testing lab. We found there's a lot of differences in how people are able to access and use technology. So what we said is, okay, this is really cool, this is really interesting, but maybe, just maybe, we should add a little bit more science to the mix. Because we hypothesize that depending on the neuropsychological profile and abilities, both visual, auditory, and fine motor of an individual, has a distinct impact on the usability features or the user interface on these mobile devices. Okay? So we wanted to figure this out. We wanted to get some really specific information. So what we did is we spent about a year with Dr. Michael Greer, who is our neuropsych consultant on our RARC project, and we came up with a core set of instruments, and I'll talk a bit more about that, so that we could establish baseline functional characteristics of every single person that comes through our usability lab to test the different products and to participate in this study I'm going to share with you in just a second. And then, of course, my team spent months becoming credentialed to actually be able to administer these tests. And then we had to develop a simulation system. So, of course, we put that off on one of our students, Chelsea Daniels, who got started with building the first simulation. And we've now launched this study. So I want to tell you a little bit about it. What we are interested in is taking these UIs and breaking them down into the very basic components. So for example, button size, button spacing, activation area on the buttons, and then build from there. And we'll talk more about our next steps on this in a minute. And we look at time on task and error rates, and we want to associate those features or those factors with the cognitive profile. So we are looking at visual spatial skills, perception, semantic verbal fluency, learning and memory, perception, auditory comprehension of language. We're looking at processing speed, executive functioning, word reading, identification, visual spatial memory, auditory attention, and the list kind of goes on from there. And what we're doing then is trying to correlate that profile and those specific abilities of that individual to these very specific factors on the user interface, because we're very curious. We want to know, can we eventually construct or deconstruct all of this to such a degree that we can then inform how we design for specific people and what that might be their personal profile. We've talked in the past a lot about personal profiles, and it kind of goes to preferences. Well, the thing about people, particularly people with intellectual and developmental disabilities, is they have such a sophisticated ability to pick up on the nuances of the people around them, and if they think you like something, they pick that. And we have tons of stuff in our clinic, in our usability lab, where we've seen this. So what we want to do is say, who are you? What really works for you? And let's figure out how to provide that with the least amount of effort. So, as I said, we're looking at this data analysis, lots and lots of big data. We now have that capability to have big data so that we can now analyze and do some very sexy math with it and bring it back down to say, okay, if we're looking at time on task and we're looking at completion time versus that digital spatial span, does that correlate? And does that matter in how you're going to have a user interface design that works for you? Now, just give you a real quick demo on this first simulation. Let's see, can you make that go? Thank you. Very simple. Touch the one that's different. I don't know with the lights if you can see that 3 are green, 1 is blue. You'll notice we're changing size, we're changing aspect ratio, and we're changing spacing. This is a very simple simulation, and it is something that can be done, doesn't require a lot of thinking to do it, but it enables us to collect a tremendous amount of data, and again, to do that analysis and correlation with the neuropsych profile that we've developed. So, next stages and what we have teed up right now, the next simulations, we're looking at numbers of buttons, shapes of buttons. We are looking at the target location, how many buttons can be on the thing. Notice these are still very simple. We haven't got to rounded corners and colors and all of those types of things just yet. We're building into that very quickly, though. And the point is, we want to know for each individual, what is your optimal button size, shape? What is your optimal interface? We want to look eventually at swiping and gliding and pinching and all of those bits and pieces that we all take for granted. And of course, yes, we'll look down the road into all the new things that are coming and how this works. Because we know that when somebody says, you know, we tried that device, it just didn't work. That device may be the best thing going for you. But if the user interface isn't there and if it's not right for you, you're not going to be able to use it. And a lot of individuals in the community, clinicians, a lot of people make the mistake of saying, this is not a good device for this person, this is not a good approach, it's not a good app, it's not a good whatever, simply because the user interface isn't set for them in a way that works for who they are, how they think, how they move, and how they hear and see. And so we're missing so many opportunities because we know there's an innate ability to do lots of things in almost every single person we meet, but we're missing that chance often because of that human-machine interface. And so we really want to take some deep attention to that, deconstruct it, reconstruct it, and eventually with all this math we're going to be able to do, have a very simple approach to a new system so that you can have that individualized profile that works for you. We think we have that capability to do it. So, do we have data? We're just getting started. We have run a handful of folks through this. Every single person that comes into our lab to do usability testing is going to have this opportunity to participate in this study. And by this time next year, we expect to have tons more data. And I want to give a shout out particularly to Greg McGrew, Levin Sliker. These guys have worked really hard to pull this together and to make these things work for us. So that's a project. This is a project I got to talk about today. I'm very excited about. I hope you've checked out our posters to see the rest of the work that's going on in our RERC. And that gets me done under time, just for you. All right.